In this video, we're going to look at a very powerful new function that's been added to VCarve version 8. And that's the ability to import a 3D model that's been designed in another program. Here we're going to take an STL file of a guitar body, we're going to bring that into the software, we're going to orient and size it, then we're going to use vector boundaries to limit the areas for the different types of toolpath to efficiently machine it. So we're going to make sure that the 3D roughing and finishing toolpath are only used to cut the 3D areas of the part. Then we're going to use the 2D toolpaths like the pocketing and profiling to efficiently machine the 2D areas like the cavities for the pickup and the neck, and also to cut out the entire shape as well. Let's go ahead and open a copy of the software to begin. We'll start by clicking on the icon to create a new file. I'm going to set up a job which is 20 inches wide, 15 inches high, Z0 off the top of the block, material thickness 2.5 inches, and XY datum in the lower left corner. Then as we come down on the form, you'll see a new section called Modeling Resolution, and this is where we can set the best quality that 3D objects will have that are imported into the software. If we click on the down arrow, you can see three choices. I'm going to choose the highest setting here, and that means that I'll have a large number of points within the work area that define my job when I import it and convert it into a 3D model within VCarve Pro. If you want to learn more about how this setting affects the quality of your work but also the speed of certain operations, then I'd recommend going to the Vectric support website, support.vectric.com, and go to the FAQs there, the frequently asked questions, and just search for resolution, and you should turn up some different documents that will help you understand this setting better. Now I'm just going to go ahead and hit OK. Now the next thing I'd like to do is import my 3D model, and you'll notice that there are a couple more tabs that we've got at the bottom of the VCarve Pro interface now. Previously we had the drawing and the layers tab, now we also have a modeling and clip art tab as well. Now if I click on the Modeling tab, this is where I'm going to get access to the functions that allow me to import and control 3D objects within the software. And the first thing I'm going to do is go to the first icon here, which allows me to import a component or 3D model. Before we load the file that we're going to work with here, let's take a quick look at the different 3D file types that we can import into VCarve Pro. You can see the very much sort of industry standard STL mesh format. Got 3DM from Rhino, SketchUp files, and then a lot of other different file types that give you great flexibility as to what 3D design or modeling package you could use to create an object to import and machine. One special case in this list is the V3M format. This is a special format that Vectric has on the Vector Art 3D clip art website and the Design and Make project clip art website. And with those files, you can actually import multiple copies into a session of the software and create an assembly. With these other files, you import a single model, then you can size and orient that before creating toolpaths on it. Here we're going to show you an example of that with an STL file, so I'm going to select the STL file format. I'm going to choose this file here called guitar.stl, and this was actually a model that somebody had created and posted onto a website for download, and I thought it would be a good example of kind of a generic sort of model that we can use to show you how the software will give you the ability to toolpath something like this. Let's go ahead and hit the open button. The software will automatically now put us into a mode that allows us to orient the 3D object correctly before it's converted into what we refer to as a component within the software. Let's take a look at what we've imported. If we click in the 3D view and rotate this around, you can see I've got a full 3D object with a front, back and sides. Now within the software I can only represent a model in a 3-axis environment, so I can't have any undercuts. So I need to orient this in such a way that it's facing upwards for the direction that I want to machine. So basically that's going to be facing up the Z-axis. So I'm going to come over and use the form here and choose the orientation that will allow me to best represent that. And if I look at this case, really the back of what I'm looking at here is effectively the part that I'd like to machine. So I'm going to click on the option for back, and you'll see that'll just turn that model there. So now it's facing upwards, which is correct. But I'd like to change its orientation by rotating it 90 degrees to get it to fit into my work area. So I'm going to click on the option here to rotate -90. So I'm happy with the orientation now, but you can see it's still too big. This area here, this box, represents my job setup size, and you can see the guitar body is much too big for that at the moment. So coming further down, I have the option to change the X, the Y or the Z axis here. I can lock those so that they scale automatically when I update one of them. I can even scale between millimeters and inches because when you bring in these mesh type files, often they don't have a particular unit assigned to them. In this case, I just need to scale the value for the X axis to be 18, hit apply, and then I'm going to click on the button to center the model in the middle of my work area. Finally, we can define the zero plane position in the model. This can act as a divider that we can use to remove a lower portion of the model if we want. We can set the slider here, set it to discard data below the zero plane and hit OK. Or in this case, I actually want to keep the entire thickness of the model, so I'm going to choose that it goes all the way at the bottom of my part. One other option to mention here is this ability to create both sides. If I set the zero plane, say in the middle of the part, I choose this option to create both sides. When I hit OK, I'm going to end up with two 3D components within VCarve Pro, one that represents the top of the job, one represents the bottom. They can then be positioned and machined in such a way that I could create two pieces to glue together, or that I could do two-sided machining with it. In this case, I'm only going to worry about the top of our model, so as I say, we're going to set this all the way to the bottom and hit the OK button. What the software will do now is take me into the regular interface, and it's created a 3D component of the object based on those settings that we just input into that import form. Here you can see it's been added to a component tree. This is what we use to manage 3D objects, particularly if we have more than one. I can just click in the background here to deselect that, or select on the name again there to reselect it. In this case, we've already sized and oriented our 3D object, but it is possible with any imported 3D part to change its position, stretch it, manipulate it using the transform tools. If I go ahead and just split the windows here so we can see the 2D view on the left and the 3D view on the right, you can see the 3D model is represented by a grayscale in the 2D view, which I can also click on to select. I can also double click on the object in the 3D view to select it as well. Once it's selected, if we go to the drawing tab here, I can use the move, set selected object size, rotate, mirror. Lots of the editing tools within here can be used to change this. In addition, if I click on it again, I go into this transform mode and you see these drag handles on it, so I can do things like rotate the object around, and you can see that updates in the 2D and 3D view, and we can stretch it. So lots and lots of different changes and manipulation we can do to this. In this case, I'm just going to hit Control Z and Control Z again in order to undo those, but I just wanted to demonstrate that this was possible with imported 3D objects. So let's just come over and click on selection mode to come out of the transform. And next what I want to do is create some boundaries that we can use for our machining. The part's effectively ready at this stage for me to cut it, but what I don't want to do is machine down the vertical edges of the part using a 3D toolpath. I want to limit the area that the 3D toolpath is going to cut and then use a more appropriate 2D toolpath in order to machine the pockets and to profile around the shape of our entire part. To do this, typically I would like to have a set of vectors that were very accurate to my 3D model, so I may have exported those from the design system that this was created in if I have them. If I need to though, I can create vectors within the software itself, and for this example, without having the vectors, that's what I've actually done. Let's just maximize the 2D view and zoom to fit to show you the way I would do this. In this case, I'd really just have to use the grayscale here as a guide to help me draw accurate shapes. If I click on an icon to draw a circle here, for instance, I might zoom in on this area and just choose in order to define the circle that I want to create for that object. I can set that very precisely if I want to a particular value if I know what that size of that hole is, and so I can create these things to very specific positions if I want to. I'm not going to go ahead and create all the vectors I need for this job here. I've already done that, so now what I'm going to do is just import that set of vectors that I've generated. As I say, ideally you would have a set of vectors that were drawn with the system where you'd created the 3D model, because they're going to be most accurate. Let's go ahead and import our vectors here. Just got a set I've created, and there you can see those vectors. So what we're working with are vectors around the areas that I want to pocket. Got a vector around the profile, vector for each of these holes that we've got here, and then I've created an offset vector around the outside where I intersected the area for the neck pocket there, so that that is going to act as my boundary for the 3D machining. And the reason I've offset that is to allow the tool to roll a little bit over the edge of the part without letting it go all the way down the vertical edge. So at this stage I'm ready to go over and do my material setup and calculate toolpaths on the part. I'm going to click on the icon to go over to the toolpaths tab. You'll notice there's a few new icons here now in VCarve Pro. For the 3D model we have 3D roughing and 3D finishing icons. We've also got the create merge toolpath icon, which is a new function dealt with in one of the other videos. Here though we need to do our material setup, so I'm going to click on the set button, and you can see there's another new area that's again to do with the fact we now have to work with a 3D object in the part, and that's where we specify that object's position relative to our block of material. I can use the slider here, or I can specify a specific value. In this case I'm going to put a small gap above the model of 0.05 of an inch, and I just need to be aware of that when I'm specifying things like the depth of the pockets for the pickups here, because I need to make sure that I add that 0.05 onto it in addition to the depth that I want to cut into the guitar body itself. So really this is not too complicated, it's just something you need to be aware of as you start to deal with 3D objects. If we come down we can specify rapid gaps. Home position here, we'll set that to 0.25 of an inch. We're working off the top of the block, so that can be relatively small, and then we can go ahead and hit OK. So we can see what's happening. I'm just going to tile the windows so we've got the 2D view on the left and the 3D view on the right. So the first toolpath I'd like to create is going to be the 3D roughing. So I'm going to come over and select the outer boundary there. I'm going to hold the shift key down and select the holes, and then also select the two boundaries for the pickup pockets as well. So now what the software will do is only create the toolpath in between these vectors if I choose that boundary option. Let's go over and click on the icon for 3D roughing. I'm going to select a 1/4 inch end mill from the tool database and hit OK. We'll just go ahead and hit edit on this and make a couple of changes to some of the values in here. Go ahead and hit OK. Now we have three options when we define the boundary for the 3D toolpath. We can use the model boundary. What that would do is just look at the edge of our 3D object or objects. We can use the material boundary, which would go to the very edge of the job setup, or in this case, because I've got quite a specialized boundary that I want to use where I want to limit the area it's going to machine within these vectors, I'm going to choose the option for selected vectors. Because I've already offset these vectors, I don't need to use this boundary offset. How you might utilize that is if you had a job where you wanted the tool to drop down the side of a part, then you can enter a value in there and it will effectively extend the size of the boundary out by that value. Machining allowance on the 3D roughing is a value that's going to be added to the model. So it's effectively like a thin skin that will be added to the model to just keep the tool away from the actual finished surface. And that just helps prevent chipping and also make sure that we've still got some material left for the finishing tool to cut. Next we choose the strategy. We can either do Z-level roughing, which is like cutting a series of pockets on the part that respect the 3D object to hog out material, or in this case, because we've got a fairly shallow area we're machining, I think I'm going to do a 3D raster cut. We can choose if we want to ramp into the part to reduce the force on the tool. In this case I'm not going to worry about that. I'm just going to go ahead and give this a name and hit calculate. And what you're going to see is the software will create a toolpath for us within those areas, so you can see it's not machining outside of those vectors, and it's just tracing back and forward over the part with quite large step over in this raster pattern, which will give me a nice clean finish on a shallow model like this, ready for me to go ahead and do the roughing. On a deeper model, or a model with a lot of Z variation within the roughing area, then you might choose that Z-level roughing option instead. To see exactly what the part will look like after we machine this, I'm going to click on the preview selected toolpath, and there we can see that animated. We can see how that's cut our part there, and now we're ready to go ahead and calculate the finishing. And this is going to use exactly the same set of vectors. So if we just close that, click on the icon for the 3D finishing toolpath, I'm going to select a 1/4 inch ball nose tool. Because we don't have much detail on this, we can use quite a large ball nose. I'm going to choose the selected vector option again, 0 boundary offset, and I'm going to raster back and forward along the x-axis predominantly by setting a raster angle of 0. So again, we've still got the same vectors selected, so that when we calculate this, the toolpath will be limited within those vector areas. Once more, we can preview the selected toolpath there. We might benefit from switching off the tool at this point to go a little bit faster. It's not too bad, still pretty fast within the software. If we look there, now you can see what our machine surface is going to look like, and we're still left with some material in the areas that we haven't cut. And now what we're going to do is go ahead and create 2D toolpaths in order to machine those areas much more efficiently and provide ourselves with a much cleaner edge than if we'd allowed the 3D toolpath to go up and down into those parts. Let's go ahead and close the preview toolpaths form. Now, one thing to notice there for existing VCarve Pro users is as soon as we close the preview toolpaths form, the preview model disappears, and that's because the software has a 3D object to display within the standard 3D view because we've got this 3D component. So just be aware of that if you're working with 3D components in the software, you'll only see the preview model when in the actual preview function itself, and as soon as you close it, it'll revert back to the standard 3D components that you're creating your toolpaths on. So the next thing I want to do is just pocket out these small holes. So I'm just going to click to deselect the vectors. I'm going to select these 4 vectors and this vector here. And in this case, I'd need to know what depth I wanted each of these to be. And I've worked out that I effectively want to go down just 1 inch from the top of the block on these. So I'm going to come in and click on the pocket toolpath option, start depth 0, cut depth 1. I'm going to select 1/4 inch end mill for this. We'll just edit the passes on that to be 0.25, hit OK. We'll choose the offset option and we'll choose to ramp. So in effect, that'll almost kind of spiral cut these out. Next, let's just change the name here. We'll call this pocket holes and hit calculate. And when we can see that being machined down into there, and we can preview those out and see how they're going to be cut. Next, I'm going to select the pickups, and in this case, I'd need to know how deep I want these to go relative to the top of the block. Remember, we've got 0.05 of an inch before we get to the top surface of our part. So let's say I wanted these to be 0.85 of an inch deep, effectively from the surface of the guitar. I'd need to add on that extra 0.05. So with those selected, I'm going to click on the pocket option, and I'm going to set this to be 0.9 of an inch deep. We've got our 1/4 inch end mill selected there, and we can choose to offset or raster these pockets out. In this case, let's stick with the offset. Again, we've got all the typical options we can choose from here. We'll go pocket pickups and hit calculate and preview that. And of course, if we wanted to, we could have set different depths for these just by calculating 2 different toolpaths. I'm just trying to keep things fairly simple here. Now, the last pocket I want to cut on here is for the neck, and you'll notice here that this has actually got some material that's been modelled into it. The pickups, what I'm seeing at the bottom of those is just the back of the guitar there. That is not the depth that the pickup pocket needs to be. Here we've actually got the material modelled in so that I can see what the depth of cut is required in order to machine this out based on the original 3D model that I downloaded. If I hover the mouse over that area at the very bottom of the screen towards the right, it shows me the X, Y, Z location of that, and I can see the Z value is negative 1.1184 of an inch. So if you have got a Z depth on the model that you want to read, you can use the cursor to pick that value up. So just need to remember that or make a note of it, 1.1184. Now what I can do is select the vector, go to pocket there, and we can set this to 1.1184 because that was measured relative to the block of material. Use the same tool as we were using before. We'll call this pocket neck and hit calculate. And again, we can preview that toolpath there to see exactly how that's going to look. So at this stage we've done well. We've machined the top of the guitar efficiently with the roughing and the finishing. We've cut the holes and the pockets that we wanted to. And the final thing, if we want to here, is just to do a cutout toolpath. Now I mentioned before that the offset for this vector here was enough to allow the tool to just roll a little bit over the edge here but not to go down the sides, and that's important. If I'd seen the tool going down the sides on the 3D toolpath, then I'd really wanted to have edited this to make sure that wasn't happening, because that's not going to give me a good finish on a vertical surface. And I can see if I look at those toolpaths how that is effectively staying pretty much on the top of the guitar there, just rolling over the edge. What that does mean though is now we can come in and select the vector which is actually on the edge of the guitar, and we can profile around the outside of this. I'm just going to type in Z equals, we'll go full depth cut. So that may not be totally practical, we'd have to have quite a long tool to do it. I'm going to select the tool that we want to use, reset the pass depth there, reduce the number of passes. We're going to cut outside the vector. If we'd want, we could utilize some of the new options we have to do things like a separate last pass. In this case, it's probably a bit deep for that option. We could add tabs if we want, all the other standard profiling things. Here, we'll just call this profile cutout, hit calculate, and preview that. And then we can double click on the waste material and see exactly what our finished machine part will look like that we've created based on that imported 3D object. So at this stage, if I was happy with the way that looked, we could now output the toolpaths using the appropriate post processor and go ahead and machine this. Now that pretty much concludes this video. It may not be a 100% realistic example, this, in terms of things like the depths and the way that I've approached cutting it, but what I was really trying to demonstrate here was how you can take a third-party model, so something that was designed in another 3D CAD modeling program, how we can now import that into VCarve Pro and then use vectors, either imported vectors or vectors we've created ourselves, in order to do very efficient machining on this. So making sure that the 3D toolpath only cuts the areas that need to be 3D machined, and that the areas that benefit better from being 2D machined, we can do that with by effectively using those vector boundaries. So hopefully we've given you a good idea of the power of this new functionality within the software. You can download the trial version in order to take a look at it yourself, work with your own files and just see exactly how it works. Thanks very much for watching this video.